Try this problem. Try to draw the resonance structure suggested by these arrows. Remember that it's futile to watch these videos if you're not trying the problems on your own. I hope that every time I pose a problem, you're pausing the video and trying the problem on your own on paper. Don't just do it in your head. It's easy to fool yourself into thinking you're getting a problem right if you're doing it in your head. Do each problem on paper. Again, if you're finding this material difficult, the way to improve is to do as much practice as possible on paper. Now we need to start by redrawing this picture. We don't just redraw the original picture, we also redraw the electron pushing arrows. By the way, let me mention something else that might seem a little trivial, but is really very important. Draw big pictures. Draw big pictures. A lot of students seem to pride themselves on drawing very neat pictures, but pictures that they fit into a tiny little corner of their piece of paper. Draw a big picture so that there's plenty of room to clearly show every electron pushing arrow and every charge. You have to have enough room so you can clearly see which of the heads are pointing to the middle of bonds and which of the heads are pointing directly at atoms. Again, you should be using a lot of paper when you're doing these problems. This is not the correct area of your life to try to conserve paper. Make big pictures. All right. We've redrawn, now we need to modify. We start at the initial arrow. This is coming from the negative charge. We know that that really means it's coming from a lone pair. Since the lone pair wasn't drawn in the first place, we don't need to erase it. But because we're at the initial tail, we need to change this charge. The oxygen is starting negative, it's losing electrons, so it becomes neutral. And now we can erase that tail. The head tells us to make a pi bond. No need to change the charges, because we're in the middle of the string of arrows. This tail is coming from the pi bond, so we erase the pi bond. No need to adjust charges. We erase that tail. This head is making a pi bond, so we make that pi bond. No need to adjust charges. We erase that head. This tail is coming from the pi bond. We erase the pi bond. No need to adjust charges. Erase the tail. This head is pointing to the sigma bond. That means we make a pi bond. Draw the pi bond. No need to adjust charges. We're still in the middle of the string of arrows. We never change any charges except at the initial tail and the final head. This tail is coming from the pi bond, so we erase the pi bond. Still no need to change charges. We erase that tail. Now we finally made it to the final head. Here we are at the final head. Now, this is pointing directly at this atom. So we're not making a pi bond, we're making a lone pair. We don't actually usually draw the lone pair, but because we're at the final head, we have to change this charge. This atom is starting neutral and it's gaining electrons, so it ends up negative. And now I can erase that head. I know I'm done because I've erased every single part of the arrows. Actually, I'm not done. Now I have to check the net charges. The net charge here is -1, and the net charge here is -1. So that balances out. If you're having any trouble with these, it might be because you're not using the redraw and modify technique. What's the opposite of the redraw and modify? Well, what most people try to do is they just try to draw the correct resonance form from scratch. They just look at the original picture and they try just out of their head to draw the new resonance structure. That doesn't work for beginning students because unless you're going arrow by arrow and modifying the old picture, you're likely to make two mistakes. One mistake you're likely to make is you might accidentally ignore one of the arrows and not make the change that's required. And an even easier mistake is to make a change that's not required. It would be very easy to make a change that was not required by any of these arrows if you're not using the redraw and modify technique. So I hope that you've really absorbed this technique and you're using it on every problem. Eventually you'll get to a point of mastery where you don't need this technique. But if you're still missing any problems, you should be using the redraw and modify technique. Don't just try to draw the final resonance structure from scratch. Start with the previous structure and its arrows and make one small modification at a time. So the way that I've been demonstrating these problems on the board is the exact way that I encourage you to do these problems as long as they're difficult for you. I've been modeling on the board the method that you should actually be using for these problems. Everything that I'm doing is something that you should be doing as well. Now, again, you don't need these methods if these problems are easy for you. But if they're easy, why are you even watching these videos? If you are sometimes missing these problems, you should be trying to imitate me exactly. I'm trying to give you the best techniques that make you the least likely to make mistakes when you're drawing these resonance structures. So I hope that you really take that to heart and try to imitate the techniques that we're presenting in the videos. Once again, notice that we changed the charge of the atom at the initial tail, and we changed the charge of the atom at the final head, and we do not change any of the other charges. Try this problem. We'll start by redrawing. Make sure that after you redraw, you double check to make sure that you've redrawn the exact original molecule and including the arrows, and put the arrows in the right place. There's no point redrawing if you're going to redraw incorrectly. Draw a big picture, a picture with lots of space, plenty of space to show exactly where every tail is, exactly where every head is, plenty of space to show exactly which atoms the charges are on. Now we'll start at the initial tail. This is coming from this lone pair. So we better erase the lone pair. And since we're at the initial tail, we have to change a charge. This nitrogen started neutral and it lost electrons, so it's becoming positive. And we've got plenty of space here to show this positive charge on the nitrogen. Make sure you have plenty of space in your own picture. We erase that tail. Now we go to the head of this arrow. The head indicates the formation of a pi bond, not a lone pair. If the head was on an atom, it would be indicating a lone pair, but the head is on the middle of the sigma bond, so we're forming a pi bond. Make sure you have plenty of space so that you can clearly show that the head is not pointing at the atom, but is pointing at the middle of the sigma bond. So we form this pi bond. Now we're in the middle of the string of arrows. There's no need to change any charges. We go on to the next tail, coming from this pi bond. We erase that pi bond. We erase that tail because there's no need to change charges. Now we go on to this head. That also indicates the creation of a pi bond. We draw the pi bond, no need to show any charges changing, erase that head. On to the next tail. The tail is coming from the pi bond. We erase the pi bond. Still no need to show any charges changing. We still haven't gotten to the final head, so we erase that tail. Now we're at the final head. Now, if I've drawn this accurately, we should be able to see this head is pointing directly at this atom. That means we're forming a lone pair. We don't need to draw the lone pair, but because we're at the final head, we have to show a charge change. This atom started neutral and it gained electrons. So it ended up negative, and we can erase that error. All right, and now a no-brainer, we have to check that the net charge is balanced. We always do that. There's 0 net charge over here, and over here there's a +1 charge and a -1 charge. So that's also 0 net charge. So that seems to have come out correctly. Remember, we're not trying to draw all the resonance structures. There's many more possible resonance structures here. We only wanted to draw the resonance structures that's forced by these arrows that I gave you. Maybe I'll make a little side note here. One of the reasons why we're spending so much time on these ideas, and I'm giving you so many examples, is that understanding how to draw these resonance structures is really important. Your instructor assumes that these problems are totally easy for you. Your instructor is assuming that these are a piece of cake. So you got to get to the point where they are a piece of cake, or the instructor is going to be leaving you far behind. But another reason why we're spending so much time and going over this so meticulously, learning how to use electron-pushing arrows for resonance, is that this is not only super important for resonance, but the skills that we're learning here will also be very helpful to you when you're using curved arrows for reaction mechanisms. Now remember, we're not doing reactions here. We're not doing mechanisms. Resonance is totally separate from reactions. Because remember, in a reaction, you change from one thing to something else. You change from the starting materials to the products. But remember, this is not a starting material, and this is not a product. As we talked about at the beginning of the videos, we're not flipping back and forth between these two pictures. Remember that there's only one picture, which is a kind of blend or average of these two pictures. So this is not a reaction, and these are not reaction arrows. But nevertheless, the electron-pushing arrows that we use for resonance are very similar to the electron-pushing arrows that we use for reactions. And if you can understand how to interpret electron-pushing arrows for resonance, that's a huge help in understanding the electron-pushing arrows for reactions. And I've been talking about how important it is to understand the electron-pushing arrows for resonance, but it's even more important to understand the electron-pushing arrows in reactions and mechanisms. Again, your instructor is assuming that those are easy for you, so you have to get to the point where they're easy. So one of the good side effects of working through all these problems is not only is it going to make us better at resonance, which is good enough and which is really worthy in itself, but it's also going to make us much more adept at using electron-pushing arrows for reactions and mechanisms as well. So again, I really hope that if these problems are at all challenging for you, you're trying each problem on paper by pausing the video. And if any of these problems give you difficulty, you'll go back and redo them over and over until they're totally easy for you. Because these are totally easy for your instructor, and he thinks they're totally easy for you.